Alright, I'd like to consider again this example of f of t equals t squared minus 4t, this particular function, and I want to consider what's the signed area under the curve from t equals 2 to t equals 4. So I want to start with my reference point a that I've called it. I want to call that 2. My reference point is 2, and I want to consider the area between this curve and the horizontal axis between 2 and 4. Alright, so I'd like to consider this question, and I would like to figure out precisely what that area is. Now, this graph that I have here claims that that signed area is about negative 5 1/3. Why is that the case? We don't know yet. Let's see if we can figure that out. So, as we had discussed previously, we know that area, and by the way, this is exactly the same question as what is the integral from 2 to 4 of f of t dt? What is that? So just another notation, more terminology for the same thing. Right? But we had discussed before that the derivative of this function with respect to x is f of x, which is x squared minus 4x. That's what the derivative of this area function is. My variable in the area function is x, and so instead of t squared minus 4t, I've written x squared minus 4x. Okay? Given that we know that derivative, can we figure out the original function? Well, we can use our process of calculating antiderivatives for polynomials like this. We can figure out that the original function, we can figure it out at least up to a constant, right? And maybe we can figure out what that constant is. Let's see. So in order to get x squared as a derivative, I would need to have a cubic, and I would need to have the correct constant out front, right? Something that goes right here. So what constant goes right there? Well, I would need 1/3, because in the power rule, when I bring the 3 down, I would get 3 times a third to cancel out and get my constant of 1, coefficient of 1, x squared. And then here, I'm going to have minus something times x squared. Right? And so what coefficient goes right here? It's not just 1. It would have to be 2. Because once again, if I were to differentiate this, the 2 would come down, and I get 2 times 2 is 4. So I get 1/3 x cubed minus 2x squared, and then we could have some constant there, right? When we anti-differentiate, we know the function up to a constant, all right? And so we've determined the area function, area sub 2 of x. We've determined that up to some constant c, and the question is, what is that constant c? Can we figure that out? Well, we know, based on the graph we're looking at, we know that when x is equal to 2, so let's think about that. When x is equal to 2, right, we know that the area is 0, because we're calculating the area between a equals 2 and x equals 2. We're looking at the area of that sliver. It's just a one-dimensional line segment. It has no area. So we know for a fact that we can conclude for a fact that area sub 2, if I plug in 2, I know for a fact that I should get 0, because I'm calculating the area under the curve, the signed area under the curve between 2 and 2. And I get the area of that line segment is 0. That I can believe, right? And then based on what I wrote in the line above, we can also plug 2 in everywhere for x and conclude that we should also get 1/3 times 2 cubed minus 2 times 2 squared plus c. Right, and so if we unite the left and right hand sides, we get 0 is equal to, let's see, 1/3 times 2 cubed, that's 8 thirds, and then 2 squared times 2, that's minus 8, plus c. So 0 is equal to 8 thirds minus 24 thirds plus c, which means 0 is equal to negative 16 thirds plus c, and then so if we add 16 thirds to both sides, we get c is equal to 16 thirds. So we know our area function, so we can plug that back in for c. Area sub 2 of x is 1/3 x cubed minus 2x squared plus 16 thirds. That's what my area function was. We determined what that constant c was based on knowing what the value of this area function should be at one particular value. So knowing what the value of the area function is at x is equal to 2 tells us what that constant c must be. We simply can solve for it as we did above. Right? So now we've determined what that area function is exactly. Let's return to the original question, which is I want to know what is the area between under the curve between a equals 2 and a equals 4, which my computer claims is negative 5 1/3. Can we verify that? All right, and so this function that we've written down is the area. It's area sub 2. Right, this function we've written down is the area, the signed area between the curve and the horizontal axis between 2 and x. In this case, we want x to be 4, as pictured in the graph to the left. And so I would like to figure out what is area sub 2 of 4. So that means I'm going to plug 4 in everywhere there's an x. I'm going to say 1/3 4 cubed minus 2 times 4 squared plus 16 thirds. Let's figure out what we get. 4 cubed is 64, that's 64 thirds minus 32 plus 16 thirds. And 4 squared times 2 is 32. Let's get a common denominator between all things. 32 times 3, 96. So that's 96 thirds. And then plus 16 thirds. So we just got a common denominator with the 32 and the other two terms there. And so if we do 64 plus 16, that's 80. And then minus 96, that's negative 16 thirds. That is the signed area under the curve from t equals 2 to t equals 4. Right? In other words, again, in other notation, the integral from 2 to 4 of t squared minus 4t dt is negative 16 thirds. And that's exactly what's claimed by my computer right here. I got negative 5 1/3, that's negative 16 thirds. That's what this green signed area is, the integral from 2 to 4 of this function t squared minus 4t.